All right, guys, we're on the back side of notes, and number 4 is talking about a designer needs to create perfectly circular necklaces. Okay, there's our keyword. The necklaces each need to have a radius of 10 centimeters, and they want to know what is the largest number of necklaces that can be made from 1,000 centimeters of wire. So when we make a necklace, number 1, it has to be a circle, okay? Number 2, because they're talking about the wire, they're talking about going around the circle, which is where the wire is going to be. And so we have to realize that this problem is talking about circumference. Okay, not area. And circumference, if you go to your reference sheet, is pi d. And so we just need to know what the diameter is. Okay. Well, they did tell us what the radius is. So a radius goes from the center to the edge, and that's 10. If you put two radii together, okay, you end up with a line segment that goes from the edge of the circle to the other edge, and it goes through the center. Okay. It's made up of two radii, and this right here is called the diameter. Okay, part plus part, 10 plus 10, the diameter would be 20. And so now we can go ahead and replace our d with a 20, and we end up with 20 pi, or pi times 20, which is the same thing as 20 pi. Okay, it's just more commonly said 20 pi instead of pi 20. All right, so we now know that that's our circumference, okay? What we're going to do is we're going to put that in our calculator so we can figure out what 20 pi actually is, okay? And pi is irrational, so this is going to be a long, ugly decimal. That's irrational as well, so bear with me. Well, we got to go ahead and write down our decimals, okay? Remember, no rounding until the end, okay? And so it's going to take approximately a little over 62 centimeters of wire to make one necklace. And they tell us that we have 1,000 centimeters of wire. So we have to figure out how many of these necklaces can be made. So hopefully you guys understand that this is division, that we're going to take 1,000 centimeters of wire and we're going to divide it by our 62.3185 ... number. Okay, remember, don't round that number, otherwise we won't end up accurate. Okay, the number of times it goes in is the number of necklaces I can make. And so we end up with 15.9154 ... Okay. And so a lot of people will say, hey, I can make 16 necklaces because that rounds to 16. However, guys, you're actually going to be a little bit short on your 16th necklace. You won't have exactly what you need. And so you can't make 16 that have the dimensions that they said. The most amount of necklaces you can make is 15 necklaces. You'll have a little bit of wire left over. You can make a smaller necklace, all right? But you can only make 15 necklaces that are going to have a radius of 10 centimeters so that they have the correct circumference, okay? So 15 is the only amount that you can make, all right? Almost 16, but not quite. All right, number 5. It says a walking path at a local park is modeled on the grid below. The length of each grid square is 10 feet, okay? And I think you guys can see that. So I'm just going to look at just this one tiny square. And because they said it's a square, it's 10 by 10, right? Okay. The town needs to submit paperwork to have the walking path. Determine and state to the nearest square foot the area of the walking path, okay? So this one's going to be a little bit tricky. Okay, there's going to be a little bit of an easy part, but there's also going to be a little bit of a hard part, okay? So what we're going to do is we're going to go ahead and find the area of this long, skinny rectangle. Okay, cool thing is that this part of the walking path is the same long, skinny rectangle, okay? And that this rectangle, okay, area of a rectangle is equal to base times height. That the base is, let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90 by 10. And 90 times 10 is 900. Okay, but this one down here is also 900. And so right now, our area is 1,800. So what do we got? Feet squared. Okay, but that's just for those red rectangles. Okay. Now what we got to do is we got to look here. This is going to be the trickier part. Okay. Hopefully you guys can see that if I take the left semicircle and put it with the right semicircle, I make a full circle. Okay. However, you got that part cut out in the middle as well. And this is what we're trying to find the area of. Okay. So what we're going to do is we're going to say that this is an area of a circle, okay, minus the area of another circle. Okay. So this is the big circle, which goes on the outside. And this is going to be the small circle, which goes on the inside. All right. So what we're doing is we're finding the area of the whole circle. And then we're going to find the area of a smaller circle. And when we take that smaller circle out, we're going to be left with this part, okay, which is where the pathway is. All right. So the area of a circle is pi r squared. And it doesn't matter what size the circle is, okay? The area of formula for the other circle would also be pi r squared. It just has a smaller radius, okay? All right, so now we have to go and find the radius of our circles. So let's see if we can use our diagram here to help us, okay? It might be helpful if we kind of draw in the rest of it as best as we can. Let's see. So it would kind of look like that, all right? So now if we're looking at the big circle, we got 10, 20, 30, 40, 50, 60 for our diameter, okay? Which would mean that our radius is 30, okay? And so on our big circle, we're going to keep the pi. The radius gets replaced with a 30, and we have to square it. That's what the formula says, okay? And so when we square 30, we get 900 pi, all right? So now we're going to go ahead and look at the small circle. So the small circle, which is here in our diagram, has a radius of 10, 20, 30, 40. So a diameter of 40, which would mean a radius of 20. So we're going to keep the pi. We're going to replace the radius of the small circle with 20, and we're squaring it, okay? And so this is 400 pi. And 900 pi minus 400 pi, because they both have pi, they become like terms. 900 pi minus 400 pi is 500 pi. So now we have found the area of the two half circles, those two rectangles, and now we're going to go ahead and total them, which means we have to add them together. Okay. And so we're going to type in our calculator 1,800 plus 500 pi, and it gives us a grand total of 3,370.796 ... They want us to go to the nearest square foot. So the nearest foot would be the 0. Look next door. It's going to round it up. And we can finally say that our area is 3,371 feet squared. That was a tough problem. Okay. But we did it. Good. All right. We're also going to talk about population density. Okay. Population density is the population divided by the area. Okay. For instance, if you ever heard about people per square mile or bacteria per square millimeter, okay, that's population density. So in number 6, it says into 2010, U.S. Census populations and population densities are shown in the table below. Based on the table above, which list has the state's areas in square miles in order from largest to smallest? Okay. So we want to know the state's areas. So notice there's no area in here. We have population density and we have population, but no area. But if we go back up to our little formula here, okay, we know that population density, let's call it D for density, is equal to your population divided by your area. Okay. So what we could do is we could go ahead and put this over 1 and cross multiply, and we get population is equal to the density times the area. Okay? If we divide by the density, we can find out that the area is equal to the population divided by the density. And we can change the formula around to get what we want, since we want area. Now we have area equals. So basically, we're going to take the population, which is the last column, and we're going to divide it by the density, which is the middle column. Okay, and then we'll be able to get the areas. So here we go. Let's go ahead and talk about Florida. Okay, we'll use F for Florida. So if we take Florida's population and we divide it by the density of Florida, we're going to realize that Florida has an area of, 53626.1. Okay. Let's go ahead and put that next to Florida so we can see it up here in our table. 53626.1. Okay, let's go to Illinois. We'll use I for Illinois. Okay, we'll take Illinois's population, which is 12,830,632, and we're going to divide it by the density of Illinois, which is 231.1, and that's going to come out to equal 55519.8. All right, let's go ahead and do New York. We'll take, the formula says to take the population and divide it by the density. Okay, and that's going to come out to equal 47125.7. And we got one last state, Pennsylvania. Take the population, divided by the density, and that's going to come out to equal 44742.4. All right, and now we're going to rank them. They want it from largest to smallest. So the largest number we came up with looks like Illinois. Next largest would be Florida, coming in at second. Next largest would be New York, coming at third. And the smallest would be Pennsylvania, coming in fourth. And so we're looking for Illinois, then Florida. And the only one that has Illinois first is number 1. All right. And so hopefully that helps with population density. All right, guys, I'll see you guys on the next Give Notes.